Hi! In this video, we're going to talk about joins. Understanding joins and knowing how joins work is so critical in database work. In this video, we're going to talk about what joins are, the different types of joins, questions you can answer with these types of joins, and I'm also going to walk you through very specific examples using syntax in SQL Server. I'll see you in a bit. Oftentimes when you work with databases, the data that you need to pull or display or put in a report, they reside in different tables. So we need a way to put them together. This operation is called join. A join is an operation that allows you to combine multiple tables together based on common fields. With this operation, you're going to get access to all the fields from all the tables that you're using in your joins. Usually in transactional databases, the structure that you're going to see is going to be similar to this. This is a typical design that you're going to find when you have what we call normalized databases. You're going to have some strong entities, and if these strong entities have many-to-many relationships, we are going to resolve them using what we call associative tables or associative entities. Before we go through the different kinds of joins, I want to answer a few questions first that often come up when we talk about joins. The first one, does the associative entity have to have a composite primary key? And the answer is no. It's more of a design decision. When you're first starting to learn databases, in a lot of the books that you're reading or a lot of the resources that you come across, they're going to show the associative entity with a composite primary key. A composite primary key means that one of the keys come from one of the tables and the other key comes from another table. So they're both foreign keys into this one table, and you've technically assigned them another constraint called primary key, which means they're going to be unique and not nullable in this one table. However, it's just a design decision. You can very well have another primary key and just leave these two as foreign keys and not add on another constraint. Another common question that comes up is, does the join need to happen on the primary key and the foreign key relationship? Do we need to have a primary key and foreign key before we can do a join? The answer is no. We don't have to join on the primary key and foreign key relationship. There are times and there are reasons where you're going to be joining just on some common fields that are not necessarily the primary key nor the foreign key. This is another common one. How many columns are you going to have in your resulting table? In a lot of the books that you're going to read when you're starting out and trying to learn databases, they're going to simplify the results. It makes it easier to understand those first basic concepts. However, the number of columns you're going to get will be the number of columns from one table that you're joining plus the number of columns in another table that you're joining. A common misconception is that when you join based on a common field, that common field exists only once in your resulting table, and that's incorrect. You may decide after the join to display only one of those fields, but the immediate result retains both columns. When we think about it, these fields have actually very different meanings in the tables that they reside in. For example, a customer ID in a customer table means a customer exists in that master list, in that customer master list. A customer ID that resides in an orders table means a customer that has purchased or has ordered from us. Again, those are two very, very different meanings. Let's now start talking about the different types of joins. The setup that we're going to use for our examples will be this. Let's assume that we have a database that has students, courses, and then their registration information. The registration table is what we call our associative entity. This table helps us resolve what we call many-to-many relationships. What we're saying is a student can take many courses and a course can be taken by many students. The different types of joins that we're going to talk about will be inner join, outer join, cross join, and self join. There's also different types of outer joins, left join, right join, and full outer join, and we are going to talk about all of those in this video as well. First, let's talk about an inner join. An inner join matches records based on common fields that you specify. For example, if we were doing an inner join on student and registration based on student ID, The operation will find matching values based on those student IDs. What's important to note is that inner joins are destructive joins. It's destructive because it doesn't keep any records that don't match. For example, in here, we have student ID 1 that matches 3 times. So it's going to keep all of these records. Student ID number 2 also matches a record. However, student ID number 3 does not have a matching record in registration. Therefore, student ID number 3 will not exist in our result. So our result will only have 4 records. And note in here that the first 2 columns are coming from the student table, and the next 4 columns are coming from the registration table. Student ID number 3 does not exist because it doesn't have a corresponding value in the registration table. An outer join is a type of join that is a preserving join. It will match up records based on the common field that you specify. However, depending on the type of outer join, because we have 3 types, we have left, right, and full outer join. Depending on the type of outer join, it will preserve either the table to the left of the operator, table to the right of the operator, or both tables from both sides of the operator. Let's take this example. If you were doing a left join on student and registration, and you've placed student to the left of your join operator, so student is to the left, a left outer join will preserve all records from the student table. Please remember that right now we're only talking about the joins. There are possibilities that some records are going to be excluded later on in your where clause, but at the join level, all records from students will be preserved. And it will also find matching values on the registration table. So in this case, it will find a match for student ID number 1, so it's going to be 3 matches in here. Student ID number 2 will also match. However, student ID number 3, even though there is no matching record in registration, it is going to be left in the result set. So we can see in this result that student ID number 3 is left in our result. However, the columns that correspond to registration are left as null. A null means a missing value or a non-existent value. It means there's no match for student ID number 3 in the registration table. A typical question we might ask for this type of join would be which students have not taken any courses. And in this case, we can see student ID number 3 has no corresponding record in registration. Therefore, this student has not taken any courses from us. How about a right outer join? It is important to note that outer joins are positional. A left outer join will always look to the table to the left of the operator and preserve just that side. A right outer join will look to the table to the right and preserve that table. If we, for example, switch registration and student in our query and moved student to the right of the join operator and this time used a right outer join, it will still preserve student. So if this was a right outer join, 1 will match up a few times. So in here, it's going to match that. 1, 2, and 3. 2 will match up again. 3 will still not match. However, because this is a right outer join, an outer join which is a preserving join, we are still going to see student ID number 3 in our result set. So it's only the default positions that have changed, but technically we have the same result as a left outer join. And remember that in a database query, we can move our columns around in our select clause. Here is another example of a right outer join. If we were doing a right outer join between course and registration, and course is on the right-hand side of the operator, it's going to retain all of the courses, whether or not those courses have been taken by students. A typical question we might ask for this type of operation will be, which courses have not been taken by students? And again, we can answer this question using a left join as well. So left joins and right joins are really equivalent. Our choice of using a left join or right join sometimes is based on our own preferences, or sometimes it simplifies some queries if you go from one direction or another. How about a full outer join? In a full outer join, we preserve tables from both sides. And technically, the result of a full outer join is the result of your left join stacked on top of the result of your right join. In this case, if we were doing a full outer join on these two tables, registration and course, it means that we are going to find all of these records, whether they have corresponding values on the right-hand side, and we're also going to find all these courses, whether you see them in the registration table. Note in here that in registration, we have a course ID comp 3838 that doesn't exist in our course table, and it's going to be preserved in our full outer join. Notice as well that comp 4677, although it hasn't been taken by students, it will also still show up in the result of our full outer join. I just want to note in this case that having a course ID in the registration table that does not exist in our course table in our main course list is a data quality issue. All the courses that we have in registration must exist in course. Otherwise, we're technically saying that students can take some phantom courses that don't really exist in our main course list. A cross-join is what we call a Cartesian product. And what it does is it basically pairs up a record from one table to all records from another table. It's a product operation because the total number of records you're going to have in your result will be the number of records from one table times the number of records you have in another table. So you have to be very careful when you're doing this. You need to know why you're doing a cross join, because even small tables can produce a lot of records. So in this particular example, if we are doing a cross join between student and course, it is basically going to take every record from student, match it up for all courses. The next student, match it up to all 3 courses. The third student, match it up to all 3 courses. Your result will look like this. A self-join is not necessarily another type of join. A self-join can either be an inner join or an outer join or a cross-join. The key thing in a self-join is you're joining that table to itself. And when you're doing this, you need to make sure that the tables have different names or different aliases. So in a self-join, it is important that you refer to the tables differently in this operation. I hope you're finding this video useful so far, and if you haven't subscribed yet, please consider subscribing. Let us jump to SQL Server Management Studio. In here, I've already set up a sample database, so I've called my database SQL Bell. And in here, I have 3 tables. I have the student table. I've also populated this with the exact same records we had in the slides. I also have the course table, as well as the registration table. I purposely did not create any foreign key constraints because we are going to demonstrate some data quality issues with our data. The diagram of our mini database looks like this. Again, there are no foreign key constraints. That's why you're not seeing any lines between any of these tables. So for an inner join, the question that we might be asking will be which courses did students register in? In this case, we can just do a select star from student. We can give it an alias. And we can go ahead and join this to our registration. And we're also going to specify exactly how we're joining these. And right now we are using the student ID as our common field. When we execute this, we can see in this result set that we don't see student ID number 3. So remember, inner joins are destructive joins. It will take away any records that don't have matching values in the other table. I'm going to copy this exact same query, and we're going to use this for our left outer join example. In here, a question that we could be asking will be which students did not take any courses. And in this case, I can simply change my inner join to a left join. So instead of inner, it's going to be left. And I'm also just going to place them on the same line so it's easier for us to see what happens with a left join or any kind of outer join. And let me just execute this so we can see the results side by side. A left join will preserve all the records from the left table. And we can see in here that all the students are appearing in our result set. Student ID number 3 that does not have any matching registration records will have nulls for all of those columns that belong to registration. Note also in here that I have not typed in outer because the outer keyword is optional. We don't have to type that in. I have mentioned previously that left joins and right joins are technically equivalent. We can achieve the same result set using either of these operators as long as we place the tables correctly. So in this case, if we wanted to achieve the exact same result set using a right join instead, we can do it. So let's try that out. I'm going to copy this query over. So in this case, instead of a left join, we're going to specify right join. And instead of students being on the left-hand side, we are going to move the students to the right because we want to preserve all the students. Let's move registration to the left. And from a display perspective, if we want the exact same result, we're just going to have to display all student columns first. So s.star, comma, registration.star. I'm going to run these two queries together, the one with a left join, the other one with a right join, just so we can show that the results are exactly the same. And these are the results. Please note that these two queries don't necessarily answer our question right away, which students did not take any courses. That will require that we add a where clause. So in this case, we could potentially have a where clause. The registration student ID is null. Okay. And if we execute this now, we're going to find student ID number 3, the student who has not taken any courses. If we wanted to answer the question which courses were not taken by students, and in this case using a right outer join, this indicates to us that we need to preserve the courses even though they don't have any matching values in registration. So in this case, select star. From, we're going to start with registration, give it an alias. We're going to do a right join course C on registration.course ID is equal to C.course ID. So we're matching on the course ID. That's their common field. And again, to directly answer the question, we typically need to have a where clause that finds the one that has a non-matching value. So in this case, where the registration course ID is missing. Let's execute this. And it looks like comp 4677 has not been taken by any of the students. If we want to display all registrations and courses, regardless of whether they have matching records on the other table, we can use a full outer join. In this case, let's copy our query from the right outer join because it's going to be very similar. All we're going to change is the keyword. The right join now becomes a full join. And again, the outer keyword is optional. So if we execute this, so this is our result. And in here, we can find that there is a record where the course fields are null or missing, which means there's no matching values. And there is also a record where all the registration columns are null, meaning there is no matching values for comp 4677 in registration. So a cross join is a Cartesian product, meaning it's going to match up records from one table to all records in the other table. So to demonstrate this, let's just quickly query all students in all courses. If we do a cross join, we're going to match up every student to every possible course. This also means that the number of records we're going to have will be the number of records in the first table, which is 3, times the number of records in the other table, which will be 3. So 3 times 3 is equal to 9. There's a couple ways we can do a cross join. So let's set this up first. Select star from student. In SQL Server, there is a keyword called cross join, so we can simply type that in, cross join course, and let's execute this. So in here we can see that all the courses have been matched up to all 3 students, and we have 9 records altogether. Instead of a cross join, we can also simply just supply a comma. That's an old style join. So instead of a cross join, replace that with just a comma. We're going to get the exact same result. So again, be very careful with cross joins. Even with small tables, you can generate a lot of records, and that could be a lot of trouble. Imagine having a small table with 1,000 records and another table with 1,000 records. That automatically generates 1,000,000 records in results. And for a self-join, it's simply joining that table to itself. And the key thing is making sure that you have a different alias when you're doing a self-join. So in this hypothetical query, so let's assume we want to do a self-join for registrations, trying to figure out the number of terms between course registrations for a particular student. So our query could look something like this. Select star from, and here registration. For now, I'm going to assign it a different alias. Let's call this R1. And let's just say we're doing an inner join. Inner join registration, different alias R2 on, and in this case, perhaps we are looking at the student. So let's say R1 dot student ID is equal to R2 dot student ID. And perhaps what we want to know is where the student terms are different. So in this case, where R1 dot term is not equal to R2 dot term. This query will probably not generate any meaningful results, but this is really just to demonstrate how we could do a self-join in SQL Server. That's it for our lesson on joins. I hope you found it useful. And if you're already familiar with joins, hopefully you found it a worthwhile refresher. I'll see you again next time.